Hello everyone, it's Mrs. Ruscio talking to you all about the 6.11 solving equations linear versus quadratic notes. Now I'm going to tell you that this video is important, not just because I'm a big deal, because I'm pretty amazing, although my students would probably say I'm pretty crazy, which I would also agree with. But I will tell you that this topic here is like such an important topic in algebra because kids always have questions. You know, they always think it's one type of solving versus the other, and then they end up making lots of mistakes. So we wanted to spend an entire day or lesson talking about the differences between linear and quadratic equations and solving. So you know that in this unit, we have solved like crazy people over and over and over again. So we've been solving quadratics pretty regularly. But up until this particular unit, you have been used to solving linear equations. This unit is quadratic. So there's a bunch of tips up top that you can see. There are linear equations and there's quadratic equations. There's actually more. We just aren't going to talk about how to solve them this particular year. The first thing that you should identify is that the variables will just never have powers. Well, they're going to have powers. It will be to the power of 1. A quadratic is going to have the highest power of 2, so squared. It could be y squared, it could be z squared, but that's the highest power. So solving, they're two different beasts. Solving a linear equation, you're going to balance. You're just going to use inverse operations. We're going back to like 6th grade, 7th grade when you solved an equation, adding something to both sides or using the sorting method. Quadratic, on the other hand, so balance or sort, quadratic to solve is setting equal to 0. For the most part, we know that there's an exception with using roots. But here's an example number 1. The first thing that I will say as a disclaimer is you look at example number 1 and immediately you're thinking, oh, this is linear. There's not any squared terms in here. But the problem with that thinking is we have parentheses, which means multiplication can change sometimes. You know, it can change the way it might originally look. Because if I distribute this y and I multiply the y into the y in the 5, I actually end up getting y squared minus 5y equals 24. So right away, well, I shouldn't say right away, after the first step, I'm noticing that this is quadratic. And why is it? Has an x, not an x squared, it has a y squared. Okay, so what method are we going to use to solve? Well, I'm noticing that it has a y squared, a y term, and a constant term. So I know that inverse operations is out of the picture. Well, I don't know. Let's get it set equal to 0 first. So y squared minus 5y minus 24 is going to equal 0. All right, so right now what I'd like for you to do is graph it on your calculators. I'm going to do the same. All right, here she is. Now, why would I have you do that? Well, because I want to look at the roots, and I'm noticing that my roots are intersecting at integer points. A couple other things that I want to point out. I had to type it in, well, I like to type things into function form, or like function notation. So instead of typing in 0, I'm going to make that my f of x. And I had to use x squared minus 5x minus 24 instead of using the y's in the problem. All right, getting back to the method we're going to use to solve in y, we have integer roots. So what method would this be? If you said factoring, you are correct. Dun, 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 dun. So factoring y, because we have integer roots. Now, the really great part about that is when we factor, first going to check for a GCF. Don't have one. And we know that it's going to take this structure. So y, and then remember, we can use our zeros to help us work backwards. So we're at -3. So one of the factors over here had to be +3, and the other one is +8. So this was going to be a -8. Does this work out if I were to do the box method? 3 times -8 is -24. Yup. -8 plus 3, -5. Yup. So that works out. All right, so we're almost done. We have to now solve. So we're going to take each of those two parts. I draw a little t-chart. So y plus 3 equals 0. So y equals -3, which we knew, duh, it's on the graph. And then y minus 8 equals 0. And then y equals 8 is the other 0, duh, on the graph. All right, example number 2. Check it. Ooh, there's parentheses. So before we commit to our final answer of whether or not this is linear or quadratic, which is going to tell us the strategy that we're going to have to use, I'm going to distribute. So distribute, dun, 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 and I end up with -13 plus 8x minus 6 is equal to 4 plus 2x minus 5. Now I know what all of y'all are thinking. You're thinking, hey, there's no x squareds, so this has to be linear. So we're going back to the basics, unit 1, hooray! How do we know it's linear? There's just x. There's no x squared, it's just plain old x. All right, I'm going to do some sorting. Let's sort. There's so many terms here. I think sorting is going to be fabulous. So -13, that's a constant, gotta go. 8x has a variable, you get to stay. -6, that's a constant, you gotta go. And remember, when you gotta go, you gotta switch the signs. You thought I was gonna say something else, didn't you? 4, let's bring that down. Plus 2x, gotta go, make it negative. And the -5, you are where you're supposed to be, bring it down. All right, 8x minus 2x, that's easy, 6x. All right, 13 plus 10 would be 23, equals what? 18. Oh no, what just happened here? Okay, let's scroll down. Okay, equals 18. And my last and final step, oh, look at this pretty blue color. Divide both sides by 6, so we get x equals 3. And you know what? I never answered this question over here. What method will you use to solve and why? We use the sorting method. And we wanted to get, why do we use it? Because needed to get x alone. Just on one side. All right, next page. Here we go. Here we are at with example number 3. So solve for x, round to the nearest hundredth. Is this linear or quadratic? You guys know what this is. Yes, it's quadratic. How do we know? Because of the x squared. So what method are you going to use to solve and why? Well, we have a few different methods, right? We have factoring. We have inverse operations, or using roots to find roots. We also have complete the square. What would you do? Let me highlight this. What would you do? If you said quadratic formula, I'm on your side. So let's use a quadratic formula. Why did I pick this? Well, for starters, it said rounding. Rounding was involved. And whenever there's rounding involved, we want to use a quadratic formula. Also, another thing to point out is that that x term is not even. So when that x term is not even, I don't like to use complete the square. Well, when we solve a quadratic, what do you have to do first? If you just thought in your brain, set equal to 0, you're amazing. Good job. So I'm going to bring everything on the side of my positive 2x squared. I know some of you might want to bring everything over to the other side, but you know what? Bring everything to that positive leading coefficient. Don't make that negative. That's gross. So 2x squared plus 5x minus 8 equals 0. All right, you're going to sing the song with me? X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That was so fun. Okay, next, what do? Skeleton template? Yes, you are correct. So x equals negative something. If you're Mrs. Hayes, she does this off to the side. Just kidding. She does the b squared off to the side. So b squared minus 4ac all over 2 parentheses. And what is our a? Our a is 2. There she is a couple times. What's our b? 5. Plop that little dude in there. What's our c? -8. We're going to plop that one in there. All right, so if I jump to my calculator, I always need to type in exactly how I see it. 5, whoops, that's not how I'm seeing it. Get it out of there. Squared, here we go. Minus 4 parentheses. If you don't know what I'm doing here or I'm moving too fast, go watch the solving using the quadratic formula video. I just simplified underneath the square root. Now, some of you might say, Mrs. Hayes doesn't make me do this, or Miss Coppola tells me to stop. Mrs. Ruscio is evil, and I do make you show this step. Well, not because I'm evil, just because I know it's helpful. Okay, so we now get to this point. Now, we're almost there. We get 2 answers. Remember, it says round to the nearest what? 100th. Okay, here's the deal, guys. We are going to type in one of them as the adding and one of them as a subtracting answer. And what I'm talking about is this right here, that little nugget. So I'm going to use my calculator. You ready? You ready? Okay, Control divide is going to give me my template. -5 plus the square root of 89 all over 4. I'm going to put enter, and if I round to the nearest 100th, I'm going to get x is equal to 1.11. Okay, now instead of wasting all my time by typing it in again, I'm going to hit enter after I've arrowed up, and I'm going to change it to subtraction, and I end up with my other answer is x equals -3.61. All right. Cool. That was fun. All right. Example number 4. How am I looking on time? You probably are going to hate me right now. How am I looking on time? Let's see. 12. Okay, let's go fast. All right. This is so fun. Okay, we don't have to go fast, but the video is going to be longer than 10 minutes because it's already 13. All right, so solve for x. Leave your answer in simplest radical form. This one here is a sneaky little snake because you look at it and you might say, hey, there's an x, but it's really an x squared because of this little guy here. Okay, so this is quadratic because of that squared. Okay, now here's the thing. We could double distribute. We could do all of this, but this is that delightful little package of the square roots, using square roots. Remember how we used to do this? So it says, leave your answer in simplest radical form. That's a dead giveaway that this is not factoring. We could look at it on the graph, but you're going to realize that we're going to get some really nasty irrational roots. Look at the clues in the problem. We're not rounding. So because we're not rounding, or excuse me, because it doesn't, or it says to do something like other than just like solve, it says to write your answer in simplest radical form, we know that our answer is going to be kind of messy, meaning factoring out of the picture. Instead, we are going to use taking the square root of both sides. What happens when we do that? Well, we get x minus 5 alone, because we did that to cancel those dudes out. And we get x minus 5 equaling the square root of 28. So what method did we use? We used inverse operations because it was written in the inverse operations form. Something all squared equaling a number. It was in that form. All right, so now we're at the point where we got to simplify the square root of 28 because it says simplest radical form. It's a bummer that it didn't tell me to just round because then I could do something with my calculator. But we got to use our brains for a little bit. What 2 numbers multiply to 28? One of them has to be a perfect square. If you said 4 and 7, you are correct. So x minus 5 is going to equal, when you take the square root, you put a plus or minus. I get all these songs from Mrs. Hayes. She really likes to sing, but I love these songs because when I sing it, I don't forget to put the plus or minus. And then another thing that I've learned from Mrs. Hayes is she just does this little arrow thing and plops that little dude right over there. So she's like, yo, x is equal to positive 5 plus or minus 2 square roots of 7. Mic drop. I'm going to stop talking now.